Hello, in this video I'm going to address cancellation with trigonometric and inverse trigonometric functions. Now, normally when you're working with inverses and functions and their inverses, you can apply this cancellation rule as long as the domains and ranges work. So f inverse of x equals to x, because basically x is taken somewhere and then taken back. Everything's undone. Same thing with f inverse, f of x. So whatever you put in is exactly what you get out. Now, with trigonometric inverses, you have to watch out because there's some trouble spots. So here, when you look at the composition of these, it does matter what order you've got them in. So if the inverse trig function is on the inside, then the first question you have to really make sure is it a valid input? And by valid input, I mean that sine and cosine can only accept numbers from -1 to 1 included. Secant and cosecant can accept all numbers except numbers from -1 to 1, not including the endpoints. So essentially 1 and -1 are okay. And then tangent and cotangent can accept all numbers. So obviously if the input is not valid, then you have no solution. Otherwise, you just use the cancellation rule, and it's just x is the answer. So for trig functions, if you have the trig function on the inside, then you've got to ask yourself, is the input or the angle given in the range of the inverse function? If it is, you can use the cancellation rule, and the answer is just x. But if it isn't, you can still do it. You just can't use the cancellation. You have to evaluate the trig function and then evaluate the inverse trig function. And what I mean by in the range of the inverse function, I mean this, right? It has to be in these intervals. All right, so let's take a look at some examples. So here, let's say you're asked to evaluate sine and inverse sine of square root 3/2. Can I use the cancellation or not? Well, here I would look and I'd say, okay, the inverse trig function's on the inside. So I want to know, is this input valid? And with sine, as long as you're taking the inverse sine of a number between -1 and 1 included, you're fine. And square root 3/2 is fine. It's about 0.87 or so. So this is good. So I can use the cancellation law and say sine and inverse sine of square root 3/2 is just square root 3/2. I'm applying the cancellation law. F inverse of x is just x. Okay. All right, let's take a look at another example. Suppose you have sine and an inverse sine of square root 3. Again, you want to know, is this a valid input? Now, square root 3 is about 1.73, so that's a number outside of -1 to 1. So inverse sine can't handle that. So this is no solution. Let's take a look at another example. And by the way, let me just kind of mention, let's see if I have, yes I do. Why is it that last one, let's just kind of remind you, why is it that you couldn't handle it? Remember, sine and cosine only go up to 1 and go from -1 to 1. So if you're trying to say, well, square root 3, which is way up here, sine was never ever able to map an input there. So how would you expect to get back through an inverse? You can't. So that's the idea there. All right, so then evaluate this. Now in this case, you have the trig function on the inside, right? And you just have to make sure that this angle is in the range that's in the inverse range. So pi/6, is it in there, in here? Yes, it is. It's over here. So this is fine. That means I can use the cancellation and say that inverse sine of pi/6 is just pi/6. Okay. Now what about here? Inverse sine of pi/6. So again, you've got to see if this angle is in here, and it's not. 5 pi/6 is over here. So what do we do? So in this case, you have to evaluate the trig function, meaning find the sine of 5 pi/6. Then that number, right, it becomes the input to the inverse trig function, and you evaluate the inverse trig function. So let's take a look at that. So at 5 pi/6, which is over here, you have negative square root 3/2 and a half. So the sine is the y value, so essentially you're saying that this, when I evaluate it, I get a half. So now I can evaluate inverse sine of a half. Now a half is a valid input for the inverse sine. So then I ask myself, for what angle in here, right, is the y coordinate equal to a half? See, my cat's helping us out. So where is it that y is a half? A positive a half. So it's going to be over here at pi over 6, right? Because pi over 6 has square root 3 over 2 and then up a half. So that's what we're looking for there. So the answer is pi over 6. Okay. Now what I would suggest, I'm going to put some here for you to try. And go ahead and see how you do with these. Just pause the video and give those a try. All right, so for number 1, inverse cosine of 7 pi over 6. All right, so this is one where you can evaluate it. Is it inside the range, the accepted range? Let's see, where's my... There. No, because 7 pi over 6 is over here. So we're going to have to evaluate the function first and then evaluate the inverse function. So cosine of 7 pi over 6 is over here, right? Whoops, sorry. 7 pi over 6, and that's negative square root 3 over 2, negative a half. The cosine is the x-coordinate, so when I evaluate this part, I get cosine inverse of negative square root 3 over 2. So now I ask myself, for what angle in 0 to pi, right, is the x-coordinate equal to negative square root 3 over 2? And that would be here at 5 pi over 6. Okay? And that's our answer. Because that's negative square root 3 over 2 and then up a half. But we care about the x-coordinate since it's cosine. Okay. And number 2. Secant of, secant inverse of 4/3. Now here the inverse trig function is on the inside, and I need to see if this is a valid input. Remember, we can handle all numbers except numbers that are between -1 and 1. So 4/3 is greater than 1, so that's fine. We can use the cancellation law and just say, oh, 4/3. Number 3. Cotangent inverse of a half. Okay, so I've got to check to see if this is a valid input. And remember, cotangent and tangent can accept all numbers. So I can use the cancellation law. So it's just a half. Cosecant of the inverse cosecant of a half. Okay. So again, this inverse is on the inside, so I have to check to make sure that's a valid input. And they can handle, cosecant can handle all numbers except numbers between -1 and 1. And a half is in this interval, so this is no solution. Cotangent inverse of cotangent of 5 pi over 4. All right, so this is, I have to check to make sure is the input, this angle, in the inverse range of the trig function, of the is in the range of the inverse trig function. So I've got to ask myself, okay, with cotangent, it has to be an angle between 0 and pi, and 5 pi over 4 will be over here outside. So what do I have to do? I have to evaluate the trig function first, and then evaluate the inverse trig function. So at 5 pi over 4, right, over here, we have the coordinates negative square root 2 over 2 and negative square root 2 over 2. Now cotangent is defined as cotangent of any angle is x over y. So I'm going to have this one over that one. But of course it's going to come out to be 1. 1. So all of this becomes 1, and I'm really now evaluating cotangent inverse of 1, and I'm asking for what? Theta in, and here we go, from 0 to pi. Right, that's our, right here, is x over y equal to 1. Now I can multiply both sides by y, and that would really be asking where is the x equal to the y, somewhere in here. Well, obviously it's going to be one of those multiples of pi over 4. So, but here in the second quadrant you'd have a negative and a positive, so it can't be that. It has to be positive, positive, so because this is a positive 1, so this is going to be pi over 4. Okay. And the last example. So here, I've got to make sure that this angle is in the range of the inverse. And here, where's 2 pi over 3? Over here. So that's fine. I can use the cancellation. And my answer is 2 pi over 3. Thanks so much for listening.